This is Oak Nervous White. We are going to talk about slopes today, and particularly slopes of lines, and how do we graph them. Okay. A slope is pretty much which way does a line go, the answer to that question. You will see a slope like on a highway. I always see this and I always think about a slope. I wish I had a picture for you. But sometimes it's a yellow sign and then sometimes it looks like this and then there's a car on it. And usually there's like a percent sign, 2% or something. That is a slope on a highway. 2% slope means, here's what it means. There is the rise of 2 feet, and this is the rise, 2 feet, for every 100 feet. So 2% slope. So 3% slope, it will be a little bit steeper. And they're giving you a warning about there's a slope in there, and just pay attention to your car heating up, especially for trucks. Okay, which way does the line go? All right, when we talk about a positive slope, that's the line that's going up. Positive slope. Positive slope. And this one is steeper than that. So that means that positive slope is bigger than that one. Okay, number-wise. Let's talk about negative slope. Negative slope. Negative slope. And this one is a steeper negative slope than that one. Let's talk about zero slope. Zero slope is no slope. So we're talking about just a flat line. Zero slope. Here's another zero slope. Okay, zero slope. How about undefined slope? That's a little bit difficult. So think of a situation like a vertical line. You cannot even ride on that as a car. Undefined. So think about it. It's a negative thing. You cannot ride on it. Undefined slope. Undefined slope. All right. Now that we know what the slopes look like, let's go and make some calculations. Okay. Definition. Vertical change over horizontal change. Y2 minus Y1 over X2 minus X1. What does that mean? All right. When you have X1, Y1 in here, what that means is this distance is X1 and this distance is Y1. When I have X2, Y2 here, let's put it here. This distance is X2 and this distance is Y2. So let's connect these two lines. And look how it goes. Rise over run. Here's my rise, and here's my run. Okay, what is this rise? Oops, yeah, right here, this rise. It's going to be this distance minus this one, which is Y2 minus Y1. How about this one? What is that? That's this distance minus that one, and that one is X2 minus X1. So the slope is simply Y2 minus Y1, which is this, the one that I put like that, over X2 minus X1, which is this, the one that I put like that. Okay? Now let's look at 3-1 and 3-2. 3-1. 1, 2, 3, and 1. Oh, this is really dirty. Let me go and put it in here. Oh, I'll put it here because I just messed it up a little bit. 3-1. 1, 2, 3, and 1. Okay? And 3-2. 1, 2, 3, and 2. Okay, so let's look at the slope of that line. The slope is going to be, always go and label these, that will help. x1, y1, it doesn't matter which one is x1, which one is x2. And let's write down the formula, y2 minus y1 over x2 minus x1. y2 is 2, y1 is 1, x2 is 3, x1 is 3. You have 2 minus 1, 1 over 0. And you cannot divide by a 0, right? And that means this slope is undefined. Okay, and remember, previously I had told you the slope of a vertical line is undefined, so that is pretty consistent. Okay, let's do another one. 1, 3, 1, 2. Okay, 1, 3, 1, 1, 2, 3. So that's 1, 2, and this is 1, 2. 1, 2. 1 and 2. What do you think the slope is? y2 minus y1, x2 minus x1. All right, let's do 3 minus 2 over 1 minus 1. What is that? 1 over 0, undefined again. Okay, so you do understand the undefined slopes. Okay, how about negative 3, 1? Again, we have 1, 2, 1, 2, negative 3, 1, 2, 3, 1. Here's that point. 3, negative 2, 1, 2, 3, negative 2, 1, 2. Here we go. Now let's look at that one. That's going down. So what am I expecting? I'm expecting a negative slope, and let's see how it works. M equals, label them, x1, y1, x2, y2. Write it down. y2 minus y1, x2 minus x1. y2 is negative 2, y1 is 1, and x2 is 3, minus, watch, negative 3. Pay attention to double negatives. Negative 2, negative 1, that's negative 3. And this one is 3 plus 3. That gives me negative 3 over 6, which is the same as negative 1/2. 1 rise, 2 run. Does that look like it? 1 rise, 2 run, and it's going down. Yes, that makes sense. Okay. The next one, 2, 5, 3, 7. Okay, how's that work? Again, 1, 2, 3. 1, 2, 3, 4, 5. 2, 5, 2, and 5. Here it is. 3, 7. 3, 7, 3. 1, 2, 3, 4, 5, 6, 7. It's right here. That goes up, and it's pretty steep slope. Okay? So let's label them x1, y1, x2, y2. Slope. y2 minus y1 over x2 minus x1. Plug it in. 7 minus 5. 3 minus 2. That gives me 2 over 1. 2 to 1 slope, 2 rise, 1 run. Very good. I expected positive slope. I can write just 2. Okay. Let's look at how can I draw slopes if somebody says, well, I want a line that goes through 0, 0, and that will have a slope 2, slope 3, slope negative 2, slope negative 3. So how do we do that? Let me do the slope 2 going through 0, 0. So that was 0, 0. Slope 2 means 2 over 1. 2 rise, 1 run. Watch. You go up from that point and 1 over, and now you draw a line. This is 2 to 1 slope. Okay? Let's do 3 to 1 slope through 0, 0 again. Okay? So 3 to 1 slope from 0, 0. I have to go 3 up, 1, 2, 3, and then 1. So 3 is 3 over 1. 3 up over 1. Watch, I'll do that with the ruler. This is 3 to 1 slope. Okay? So it's steeper. How about negative 2 to 1 slope? What does that mean? Negative 2 over 1. So negative 2 means I'm going to start from 0, 0. Negative means I'm going to go down. So I'm going to go down 1, 2. Positive means to the right. So 1, 2 down, 1 to the right. Here's my negative 2 to 1 slope. 2 to 1. Okay? All right. Let's look at negative 3 to 1 slope. I'll do that in red. That one is negative 3 over positive 1. Negative 3 means you start with the point, go down 3, 1, 2, 3 over 1, and you connect those two. I'll do it with the dots. And that's my 3 to 1 slope. Okay? Now, so when you try to draw slopes, given a point and a slope, so make sure that when you have something over here, if this number is positive, you're going to go up from that point. If it's negative, you're going to go down from that point. After you do that, you'll stay at that point. You're going to look at your run. If that is positive, you're going to go right. If it's negative, you're going to go left. So remember 2 to 1, I go up first, 1, 2 over 1. If it is negative 3, 1, I go down first over 1. So do the y's first and then the x's, then you'll always be right. Okay, and the last thing I want to talk about in the slope portion, when you have two lines with the same slope, they are parallel. So let's put slope 1, and let's say it goes through here. Slope 1 means you go up 1 over 1. So here is the line that has a slope of 1. 1 over 1. All right? So this slope is 1 over 1, and it goes through this point. So let's do another one. Let me do this in blue. This one has a slope of 1 over 1 as well, but it goes through another point. So let's go up 1 over 1, and let's draw that. What do you see? Lines that have the same slope. This one is M2, and this one is M1, and they happen to be the same. They're parallel. Now let's look at lines that have slopes like this. One is positive, the other one is negative, and this one looks like it is the negative reciprocal of the other one. Okay? So let's draw a slope of 2 from 0. 1, 2 over 1. Here's my slope of 2. And I do it with the dots. This is this M1. And let's draw negative 1 over 2. Negative 1 over 2 means negative 1 over positive 2. So let's go draw one from here. Negative 1, go down to the right 2, 1, 2. Here we go. Now these don't look like perpendicular because this scale is wider than that one. But they are perpendicular, trust me, because perpendicular, if these two dimensions were the same, these two lines would have looked like that 90-degree corner. It's like the corner of your book. So if you put your book in there, here's your book, all these writings in there, this line and that line are perpendicular to each other. So actually this looks like that if the axes were not fat one way and skinny the other way. So this gives you an idea about how slope works at this point.